Hello guys, welcome back to Calculus Universalis. Today we're going to be learning the power rule, which is going to be essential in your derivatives, how to take the derivative, and it's going to be essential in your calculus career for the rest of your life. So, before I get into what the power rule actually is, we're going to talk about some techniques that you can use when taking the derivative. This unit isn't just about the power rule, that's what I simplified it to, but it's also about some techniques that you should memorize and know when you take the derivatives so that they come out quicker. The first one being the derivative of a constant. F of x equals constant c. If I have an f of x equals constant c, any derivative of a constant, its f prime of x is going to equal 0 no matter what. A constant's derivative is always 0. So that's one thing to memorize. And why? Why is this true? Because if I have a graph and it's a constant, the slope at any point on the graph is always going to be 0. So that's how you know, because the m tan equals 0. That's what the derivative is, m tan, right? So let's go into our second rule. Our second rule is going to be power functions, and this is where we get into our power rule. So what is the power rule in and of itself? If I have a function x to a to a power n, and I take its derivative, this is f of x, right? And I take its derivative, f prime of x, how am I going to figure this out without doing any plugging into that big formula? The rule is that I'm going to multiply this n on the top to the whole function itself, okay? Leave the inner function alone, and then take the exponent and subtract its exponent by 1. So now it's not to the n, it's to the n minus 1. And why does this work? Well, it was a common trend noticed, and it just became a rule that always works. Because if you think about it, you're sort of finding the linear slope, and function's derivative is always a degree below, like x to the third is going to be 3x cubed. It's always going to be a degree below, because tangent line of a quadratic is just one line. It's always going to be a degree below the function itself. So now let's do some examples of this. I'm going to start with the most basic power rule function ever. It's going to be f of x equals x squared. Go ahead and pause the video and see if you can do this yourself. So now if we apply our rule, f prime of x is going to be, our 2 is our n, so our 2 is going to come out front, right? It's going to be n times x to the n minus 1. So we're going to bring our 2 out in front, x is going to stay there, and then we're going to have 2 minus 1 on the top, which becomes 2x to the 1, which is 2x, and that is our derivative of x squared. Now you don't have to work this out every time. Eventually you're just going to know these things so you can do it in your head very quickly. Right. Now let's do a little bit more complex of a function. Let's do the function f of x equals 6x to the fourth. Go ahead and pause the video and see if you can do it. So f prime of x is going to be, multiply this. Sorry, I kind of described it badly. We're not just going to bring the n to the front, we're going to multiply it to the front. So if the front is already 6, like we have here, who cares? Still, we're going to multiply the 4. We're going to multiply this 4, let's put it in green, to the front. So it's going to be 4 times 6, because that's already there, x to the exponent minus 1, which is going to simplify to f prime of x equals 24 x to the third, and that is our derivative of 6x to the fourth. So you don't just bring the n to the front and call it a day, you bring it to the front and multiply it by the coefficient that's already there. If the coefficient's 1, fine, but if it's 2, you gotta multiply it every time. And that's a power rule. I'm going to do one more decently complex version of this, and then we'll call it a day. Let's do the derivative of, we're going to do f of x equals, this is going to be very tricky, the square root of x. Go ahead and pause the video so you can get it. So, how are we going to solve this? Anytime you have something, unless you like have it memorized in your head, anytime you have something like this, a square root, you know, a cubic root to the fifth, anything like that, instantly put it in exponent form. Instantly. Because that's what we're dealing with in this power rule, is exponents. So this really equals, it's really equal to x to the 1/2. Those are equal. So now we can apply our power rule. Right, this is our n. We're going to multiply our n to the front. F prime of x equals, bring it to the front, 1/2 x. Now our n minus 1, right? What's this going to be? This is tricky. 1/2 x to the, let's do it over on the side, 1/2 minus 2 over 2 equals negative 1/2. Yes, negative 1/2. Now, on your test, you're going to have to simplify it even more. And this is where it gets kind of tricky, especially when you get into future derivatives where they're very big and long. This is going to be 1 over 2. Now, what is x to the negative 1/2? It's saying x to the negative 1, right? Which is 1 over x. But on the bottom, it's going to be negative. It's going to be on the bottom. X to the 1/2 is the square root of x. So it's going to be 1 over square root of x. But since we have this coefficient, we're going to have to multiply it by 1 over 2. And that's how we get our 1 over 2 root x is our derivative of square root of x. So, I hope you guys enjoyed. I hope you guys learned a lot. If you did, make sure to like, subscribe, leave a comment, let me know what you think. If you have any questions, comment it on the video. And I'll see you guys next time. Bye.